Hello and welcome back to Global Climate Systems. This is the full video for Chapter 6 on climate systems. If you haven't watched the intro video, I suggest that you do that. It gives a brief introduction to climate systems. It goes over the 5 major climates. It also goes over the relationship of the ITCZ and the subtropical highs, how those work together to create weather patterns in California, also create the monsoon, also create the tropical climates. So I really recommend going to watch the Global Climate Systems Summary intro video. It covers some really important topics that I'm not going to get into here. In this video, I'm going to talk more about the individual climates and what the differences are between the climates. You're going to need to know that stuff for the test. So let's just jump in and talk about this picture, which is Alaska, and it's raining. That's about all I'm going to say about that. So we're going to talk about how are climates classified. It's going to be mainly temperature, first temperature, and then rainfall is the way these climates are going to get classified or broken down into different types of climate. What differentiates climates of tropical and mid-latitude regions? Again, it's going to be differences in temperature and rainfall. Same thing with the microthermal cold climates and also the dry climates, although the dry climates are the only ones that are first classified based on moisture, on rainfall, and then temperature. Everything else is going to be temperature first as the primary consideration, and then we're going to look at how much rain they get, when they get it. Does it rain year-round? Does it just rain for part of the year? And that'll help determine the non-dry climates. So first off, difference between weather. Weather is the short-term condition. It's what's happening right now. It's what's happening tomorrow. It's what happened yesterday. That's weather. Climate is a long-term average, so day after day after day. The last 30 years of April averaged out. That would be April climate. So climate is long-term averages. Weather is what's happening today. The study of climate is climatology. Climatology looks at long-term patterns over space and time. Looks at the controls that produce Earth's climate conditions, things like pressure belts, air masses, ocean currents, prevailing wind direction, continentality, mountains with orographic lifting on one side and rain shadow effect on the other. So we can group different regions that have similar climates together into the same climate region. Vladimir Köppen, that little umlaut makes the O sound weird. Vladimir Köppen was a genius. Started working in 1884 on heat zones. He wanted to classify climate, which was a really great idea. He said, I'm going to figure out a way to classify climate, and I'm just going to look at temperature. And then 16 years later, he had this big breakthrough, plant communities. Plant communities, it turns out, are incredibly important in the Köppen system for classifying climate. We'll look at the dry climates, where it's generally too dry to have trees. And trees turn out to be incredibly important, again, in defining a lot of these climates. The polar climates don't have trees because it's too cold. The tropical, mesothermal, and microthermal climates will have trees because they have a summertime. 1928, he published his first wall map, 44 years after he started. Here you have his name as he would have spelled it, Vladimir Petrovich Köppen. He was a Russian-born German meteorologist. He studied weather. And if we were in room 426, like we used to be in the good old days, I would pull down the wall map of the Köppen climate classification system and say, hey, look, it's the one that we still use today. He started on it in the 1800s, and it's the main climate classification system that just about all the researchers still use today for classifying climate. The 2 main components of climate, I've mentioned this before, review is good, temperature, followed by rainfall. So here's a diagram from the book of patterns of rainfall. It's the same pattern we've been seeing all semester. Rainy by the equator with the ITCZ, and then you've under the subtropical high, so it's dry, so it's dry, so it's dry, so it's dry. The world's deserts right under the tropics, world's deserts right under the tropics. And then you get up into the polar front, and it's wet and cool. The polar front, wet and cool. The polar front, wet and cool. There's nothing here that the polar front is really over. That's land, so we don't care. This is a map that I made for kicks and giggles showing average temperature, and you can see pretty clearly the main effect, the main factor that creates this pattern rather, is latitude. Here we have the highest values pretty much right by the equator, and then as you get away from the equator, it gets colder. So latitude is going to be the most important factor, followed by altitude or elevation, high elevation. You can see the Tibetan Plateau is much cooler than the surrounding regions. Same is true for the Alps here in Europe over Italy. You can see the Rockies, you can see the Appalachians, you can see the Sierras, you can see the Andes, you can see the effects of the Ethiopian Highlands, the Ethiopian Plateau. So high latitude and high elevation places are cold. This is showing temperature range. So now the two main patterns are going to be latitude, the lowest temperature ranges right on the equator, and then the temperature range gets higher and higher and higher as you move up in latitude and as you move inland. That's the effect of continentality. Notice there aren't any climates in the southern hemisphere, or there aren't any regions that have the same high temperature ranges as the northern hemisphere. Here in Canada, we're looking at 50 to 58 degrees difference in temperature between summer and winter. Those are Celsius. So what is that? About 90 to 100 degrees difference. And here we've got much more. Here's Siberia, the highest temperature ranges in the world, combination of high latitude. In fact, they're right up against the Arctic Circle, and they're well inland. Remember, the prevailing winds are from the west. So although Siberia looks close to the Pacific over here, it doesn't matter because the winds are coming from the west. So by the time they get to this part of Russia, they've had to travel inland over all of Eurasia, which is the largest continent. So temperature range patterns, again, latitude and continentality. This is going to create patterns of climate because one of the climates, the snowy forest or microthermal climates, there aren't any of those in the southern hemisphere because there's no continent at a high enough latitude to create the conditions where you would get below freezing in the wintertime and then still have summertime with 3 months above 50 degrees. Here we have rainfall. And you can see the effect of the ITCZ in the tropics. You can see the subtropical high creating desert and then back under the polar front. ITCZ, subtropical high, polar front, ITCZ, subtropical high, polar front, subtropical high, subtropical high. So this is a list of the components that create climate. Insolation is incoming energy from the sun. That's just a function of latitude. The energy balance, a function of latitude, temperature, latitude, elevation, continentality. Air masses is going to be latitude and continentality. Air masses that form over the ocean are going to be more moist, have more water than air masses that form over the land. Those are going to be drier. Air pressure, we've seen those four belts, the ITCZ, hot and wet, low pressure, lots of rain. The subtropical high pressure cells are going to be hot and dry. The polar front is going to be low pressure. Those are going to be cool and wet. And then finally, the poles are going to be cold and dry with high pressure. And every place there's low pressure, there's going to be lots of rain. Moisture and precip are a function of all those patterns put together. Here we have Death Valley. It's incredibly dry. So let's look at the five climates of the Köppen system. First off, the tropical climates. By definition, they have no chill. Every single month is above 18 Celsius, which is 64 Fahrenheit. So the first characteristic of the tropical climates is every month is warm. Every month is summer. They have no seasons. Every month, the day length, every day is about 12 hours long. Every day, every month, they're about the same temperature. The dry climates are the only climates that are defined by a moisture deficit, precip minus potet. The dry climates have an annual temperature deficit. And there's a couple different ways of classifying dry climates in the lab. We get really in-depth. In lecture, it's pretty much just precip minus potet. The mesothermal, meso means middle, thermal means heat. So the mesothermal climates have seasons. They have a summer period. They have 3 months over 10 Celsius, which is 50 Fahrenheit. And the winter temperature, the coldest month, is warmer than freezing. So the winters are above freezing. I think the book makes some reference to mild winters. When they say mild winters, what they really mean is it's above freezing. As opposed to the microthermal, micro small thermal heat, so small amount of heat. These are also called the snowy forest climates. That's my favorite term for them because it's, snowy forests, pine trees and snow. It's pretty much what you'd expect. So the microthermal climates, they have trees. They have a summer with 3 months over 10 Celsius, 3 months over 50 degrees. But the winter in this case is below freezing. So these climates have the highest temperature range, the biggest difference between summertime and wintertime because they have a definite summer. They need to have a summer, otherwise they would be some other climate. They'd be a polar climate if they never had summer temperatures over 10 Celsius. But they also have winter below zero. So the hugest, gnarliest temperature ranges on the planet are in these snowy forest microthermal climates. The polar climates, they're just cold. Every month on average is below 10 Celsius. So here you wouldn't expect to find trees either because it's just too cold. The summertime, it might thaw out. There are some polar climates, the ice cap climate, where every month is below freezing. But there's polar climates where you could have a couple months where the temperature would be above freezing, but you're not going to have conditions good enough for tree growth because they're polar climates. So here's a map showing tropical climates. There's 3 types, the 3 different colors of green. There's the tropical rainforest with rain every month, the tropical monsoon that has a couple months where it's dry, and then the tropical savanna on the outskirts. So you've kind of got, with the tropical climates, with several of these climates, there is what I consider to be a core climate that is the most extreme. So in this case, the tropical rainforest is going to be the most extreme climate where it rains every single month. Every month gets more than 6 centimeters of rain. And then as you move out from there, you get 6 to 11 months of rain with the monsoon, 6 to 11 months with the monsoon, 6 to 11 with monsoon. And then you have the savanna, which has less than 6 months of rainy season. So it starts off, every month is rainy to getting slightly drier to drier, 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 as you move away from the ITCZ. As you move from the tropical climates to the dry climates, you keep moving away from the equator. The tropical climates are right on the equator. The dry climates are on either side of the equator, right under the subtropical high. So here we've got the Sahara Desert, and on either side of the desert, there's a region called steppe. And this is steppe. So Australia, there's a core of desert surrounded by steppe. Core of desert surrounded by steppe, surrounded by steppe. And that's under the subtropical high, is where the driest conditions are. As you move toward the equator, you're going to run into rain from the ITCZ. As you move towards the poles, you're going to run into the polar front. Same thing down here in southern Africa, ITCZ precip, subtropical high, very little precip, and then little bits of storms from the polar front. Same thing with Australia. Polar front, and then ITCZ. The mesothermal climates are the climates that we live in. So Mediterranean is a mesothermal. Humid subtropical is a mesothermal. So these are rainy year-round. The marine west coast is a mesothermal climate. And as you move away, so you note, if you've been paying attention, we started at the equator with the tropical climates, we moved away to the dry climates, now we're hitting the mesothermal climates, and as you keep moving away, we're going to get to colder regions, and we're going to get microthermal climates. These are the snowy forest climates, places like New York, places like Moscow, places like Siberia. So now we've moved from the mesothermal to the microthermal climates. And then finally, we have polar climates. I should also mention on this map, there are climates that are classified as polar climates because they're cold year-round, but they're not polar. That is, they're not at the poles, right? Like here, we've got the Andes. Here's the equator. Here's the tropics. So we've got polar climates right in the tropics. If this was a more detailed map, you'd see there's some polar climates in Papua New Guinea, the Tibetan Plateau. There would be polar climates in parts of the Sierras and also the Rockies. So these, in the Andes, in the Rockies, in the Sierras, the Tibetan Plateau, the Ethiopian Highlands, the Alps, those are all highland climates. And highland climates are climates that would be something else, but they're cold because they're high. So they're cold not because of their latitude, which would make them a true polar climate. They're cold because they're high, so they're highland climates. And here they are all together. So we've got the tropical rainforest, tropical monsoon, tropical savanna, steppe, that dry climate, desert, super dry, back to steppe, Mediterranean with a summer drought, marine west coast, which is rainy year-round. They're far enough north now that they're out of the subtropical high. They're just under the polar front year-round. And then you have the microthermal climates. And finally, the polar climates. And let's take a look now. We've got the tropical climates. A lot of this is going to be review, which is great. The more times you hear it, the greater the chances you'll remember it. So the tropical climates are warm and rainy year-round, or they have a rainy and dry season. There's the dry climates, the mesothermal. They exist in the mid-latitudes. The winter is above freezing. The microthermal climates, the snowy forest climates, are at higher latitudes. They have freezing winters. The polar climates are at high latitudes and polar regions. They're cold year-round. They have no summer. And then there's the highland climates. We're not actually going to classify highland climates. That's kind of a judgment call. I don't think I've ever read anything that says, oh yeah, here's how you officially classify this as a highland climate. You kind of look at it and go, well, everything around it is not a polar climate. This is a polar climate only because of its altitude, only because of its elevation, so it's a highland climate. To look at climates, we're going to use climagraphs. Climagraphs are these great graphics. They show temperature and rainfall. So here is a climagraph for Madrid, Spain. The rainfall is a bar graph, and the temperature is a line graph. So just a glance, you can look at a climagraph and have a general sense what the climate is going to be like. The average temperature, you can tell. The temperature range, the difference between winter and summer, you can tell. Is it a big range or a small range? Is it rainy year-round? Is it dry year-round? This is showing a summer drought. And if I didn't know it was in Madrid, Spain, I would guess that it was some sort of Mediterranean climate because of this dry period in the summer. You can tell it's a summer because it's the warm season. So that's the climagraph for Madrid, Spain. This is the map. This is figure 6.6 out of your textbook. It's got the Köppen climates. It has the causal factors, so it not only identifies like tropical rainforest, tropical monsoon, tropical savanna, steppe, hot desert, steppe, Mediterranean, marine west coast, microthermal. It also shows you some of the factors like how far north and south the ITCZ moves. So there's the ITCZ creating the Asian monsoon, subtropical highs creating deserts, cold currents creating deserts, warm current creating rainy conditions. It's got a list. The legend here shows the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 climates that I want you to learn for this. It's going to be the tropical rainforest, tropical monsoon, tropical savanna. For the dry climates, there's desert, where precip is less than half of potet, and then steppe, where precip is less than potet. If you don't get enough rain, you're a steppe. If you get less than half the rain you needed, you're a desert. Then we move to the mesothermal, humid subtropical. There's two types of those. One of them is found only in Asia. Those are really interesting. Well, this year I've decided they're interesting. The marine west coast, like Seattle and Vancouver, where it's rainy year-round. The Mediterranean climates are the only climates with a summer drought. If you grew up in California, the climate that you've experienced is unlike every other climate on the planet except for the Mediterranean climates. Mediterranean climates are the only climates where summertime is the dry season. Every place else on the world, if it's summertime, that's the rainy season. So extra hard to be a plant in a Mediterranean climate because the season when you're getting the most energy from the sun, there's no water to help you grow. Then we've got the microthermal climates. I'm just going to divide those up into humid continental and subarctic. And then finally the polar climates, I'm just going to lump those together. There's ice cap and tundra, but I'll just lump those together. This diagram is really nice. It shows how these things look in reality. On the map, there's these nice crisp lines that divide the climate. So here's one boundary, here's another boundary in between the savanna and the steppe and the desert. But in reality, they just kind of blur from one end to the other. Like there's no crisp line on this. It's really green, really brown, and in between it gradually goes from green to brown. So the climate zones in reality have very indistinct borders. It just sort of gradually grades from savanna into steppe, and then it gets drier and goes from steppe to desert. So in reality, it doesn't look like the maps. In reality, it just gradually over time, over space rather, goes from one climate into another climate. So let's look at the tropical climates. The main criteria: no winter, every month is above 18 Celsius. They're classified by the length of their rainy season. They're in the tropics. Because they're in the tropics, day length is pretty much 12 hours every day. The temperature every day is about the same. The temperature every night is about the same. Rain comes from the ITCZ, or convectional thunderstorms. So one of the things I want you to pay attention to as you're taking notes is what the precip, what the lifting mechanism is. And in the tropics, it's going to be convection and convergence from the ITCZ and from convective thunderstorms. Warm ocean temperatures, lots of water vapor contributes to unstable air masses, which also makes it easier to make thunderstorms. They cover a large amount of land. 36% of land in the ocean is covered by tropical climates. Here's another map showing where they are. The dark green is going to be rainforest. The intermediate is tropical monsoon with 6 to 11 months of rain. And then you have the savanna. Tropical savanna. Those are tropical grasslands like the Lion King. So we've got the tropical rainforest. Every month is warm and wet. The rainy season is all year. The ITCZ is constantly overhead. That's why it's raining. Massive water surpluses. This is where the Amazon is, for example. So you can see here's the temperature chart for a tropical rainforest climate. Almost no change over the year. Slight dry season with only 6 inches of rain here in September. But every month, lots and lots of rain. Tropical monsoon climate. The dry season lasts for 1 or more months when the ITCZ is not overhead. If the ITCZ isn't overhead, it's not raining. Hanoi in Vietnam, excellent example. So now you can see a definite dry season and rainy season. Although it's still warm every month, there's a huge shift when the rainy season hits. And then the tropical savanna is further away from the ITCZ, lies poleward of the tropical rainforests. The ITCZ is overhead maybe 6 months out of the year. The rainy season is then less than 6 months long. Summers are the rainy season. So here we have Serengeti in Tanzania. Dry season from June to October. Much less rain all year. Still warm though. It is a tropical climate. And again, to classify the tropical climates, the first thing you look at is the temperature. And if the temperature is above 64 degrees every month, it's a tropical climate. So that's it for the tropical climates, where every month is warm and they're classified based on how long the rainy season is. Let's look at the mesothermal climates. We'll look at the dry climates last because they're classified based on moisture balance rather than temperature. So the mesothermal climates are now going to be found closer to the poles as we move from the tropics. We hit the dry climates in the tropics, and then in the subtropics and the mid-latitudes, we're going to find the mesothermal climates. So bigger seasonal shifts because they're at higher latitude. The temperatures are cooler overall. Day length changes. There's a greater change in day length over the course of a year because there's greater changes in seasonality because we're farther away from the equator. That would be one of those good short answer questions. Discuss the role of latitude in creating patterns of daily temperature change and seasonal temperature change in the tropics as opposed to the mid-latitudes. And I'd be looking for something like the tropics have consistent insolation, which creates consistent temperature and rainfall. In the mid-latitudes, however, there's a large difference in day length and insolation from summer to winter. So they have increased seasonality. Day length changes more. The angle of the sun is more important. And the temperature range is much higher in the mesothermal climates than the tropical climates. Summers are hot to warm to cool. They have at least 3 months over 10 Celsius. Precip in the wintertime is from mid-latitude cyclones, so frontal lifting is what brings the rain in the winter for the mesothermal climates. If you're on the east coast, you're going to have a rainy summer from convectional lifting. The sun shines on ground, ground gets warm. You've got all that water vapor because the air masses are coming off of the Gulf of Mexico or the Atlantic, so the water is warm, so there's lots of evaporation, so there's lots of rain from convective thunderstorms in the summertime if you're on the east coast. If you're on the west coast in the summertime, you get nothing because there's a cold current, so you don't have that water vapor. The combination of the cold current and the subtropical high act to shut down precip on the west coast in the summer. The farther you move toward the poles, the wetter it is overall. The difference between, for example, Los Angeles and Arcata is because you're closer to the subtropical high in Los Angeles, you're closer to the polar front in Arcata. As you move towards the equator, you're under the subtropical high, so it gets drier. More people live in mesothermal climates than any other climate type. And here we can see the distribution of mesothermal climates. The brown climates are Mediterranean with their summer dry. They are west coast, cold current. Oh, wait, hold on. That's a weird choice. That's a humid subtropical winter dry. That's a weird climate. This is Mediterranean. This is Mediterranean. That speck is Mediterranean. That's Mediterranean. In the Mediterranean, the climate is Mediterranean. And then the west coast of the U.S. is Mediterranean. So those have a summer dry period because of the cold current, because of the high pressure, as opposed to the humid subtropical. This is the American Southeast, parts of South America, parts of Australia, parts of China are humid subtropical, where it's rainy year-round, the polar front in the wintertime, and then thunderstorms in the summer. The humid subtropical winter dry, totally fascinating. Winter dry because the summertime they're actually getting little bits of rain. You can see where they are. Here's monsoonal patterns here. Here's humid subtropical. So it's cold enough that it's not a tropical climate anymore, but the precip is coming from the ITCZ in the summertime. So totally fascinating climate. And then marine west coast is like Mediterranean, except it's rainier year-round. There is a bit of a dip in precip in the summertime because of the subtropical high. When we look at the climograph, you'll see what I'm talking about. And for these diagrams, as you're looking at the diagrams in lecture, I'm probably going to give you diagrams like this unlabeled on the exam and ask you to tell me, what's this climate? Tell me the name, tell me the classification characteristics, tell me what the rainfall characteristics are, something like that. So you'd have to say, well, that's the humid subtropical climate. It's in between the polar front, the subtropical high. In the wintertime, it's getting frontal precip. In the summertime, it's getting convective thunderstorms. By definition, a mesothermal climate has 3 months with a temperature over 10 Celsius in the summertime, and the wintertime is above freezing. So that's what I would look for that climate. I would want you to be able to tell me that for all of the climates. So let's look at them. We've got the humid subtropical. That's going to be the U.S. East Coast, also China. Moist year-round or a dry period, depending on where they are. Summer is warm. Unstable means thunderstorms. Air masses interact in other seasons. That's frontal precip when you have two different air masses colliding. Humid subtropical winter dry, humid subtropical hot summer. So Atlanta would be a humid subtropical with a warm summer. You can see it's just rainy every month. A bigger temperature range now because we're farther away from the equator. Chengdu, China is a winter dry mesothermal climate. So the ITCZ, they get a little bit of rain in July and August from the ITCZ, but then the rest of the year it's pretty dry. Interesting climate. The marine West Coast climate has mild winters, cool summers, cool, moist. This is going to be Vancouver, Seattle. Much of England is marine West Coast climate. Characteristic of Europe and other middle to high latitude west coasts. So here we've got Vancouver in Canada. And I was mentioning there's a dip in the summer with a precip because of the subtropical high and the shift of the polar front. Here you're under the polar front in the wintertime. In the summertime, the polar front is going to shift away. And the subtropical highs are going to take on more importance. So a bit of a dry period, but they're still getting, even in the driest month, they're almost getting 2 inches of rain here in August. Seattle, very similar to Vancouver, although you can see it's a little bit drier as we're now a little bit farther south. The Mediterranean dry summer climates are all on the west coast in the mid-latitudes. The summertime is dry from the subtropical high and the cold current offshore, limiting precip availability. Wintertime, it's raining from the polar front and mid-latitude cyclones. That's what the MLC is. Mid-latitude cyclones, cold fronts, warm fronts, spinning around an area of low pressure. They're found in 5 places. Those 5 places all have good wine growing regions. They also typically have sharks offshore. So, western margins of North America, central Chile, southwestern tip of Africa, southern Australia, and the Mediterranean basin. So those are the regions that have Mediterranean climates. Like I said, they all typically have sharks. The cold water has lots of fish. Lots of fish mean lots of seals. Lots of seals means lots of sharks. Here we've got a climate graph for San Francisco showing the summer dry period. By definition, most of the rain falls in the wintertime. Here we've got a climate graph for Sacramento, which you could then compare with Vancouver and Seattle. So a bigger dip, lower precip year-round, bigger dip in the summertime as a result of being closer to the subtropical high. So here you can see Seattle and Vancouver again for comparison. Vancouver is wetter year-round, Seattle is drier year-round, and Sacramento is even drier than Seattle because it's farther south. So that's the Mediterranean and the marine west coast. Now let's talk about microthermal. The microthermal or snowy forest climates have the highest temperature ranges. They're farther away from the equator, so the day length is changing even more from summer to winter. The temperature range is changing even more from summer to winter because of increased latitude. Decreasing sun angles, variable day length, so they're less energy overall, so they're cooler, not just in the winter. Precip is going to be the same as the mesothermal climates, mid-latitude cyclones in winter and thunderstorms in the summer. Continental polar air masses dominate in the winter, so those are going to be very cold, very dry. So here are the microthermal climates. Remember, these are mesothermal, these are microthermal, mesothermal, humid subtropical, humid continental. So humid subtropical, I would just ask that you keep that in mind, that subtropical, you'd expect it to be warmer. Humid continental, the continental part is important because continentality allows them to have freezing winter temperatures. So the difference between the humid subtropical and the humid continental is continentality plus higher latitude equals colder winters. So these are microthermal, the humid continental hot summer, humid continental mild summer. I'm just going to lump those together for the test into humid continental. And then we've got the subarctic. Including the subarctic cold winter, by definition, the coldest month is colder than negative 38 Celsius, which is like negative 39 Fahrenheit. Incredibly cold. 183 Fahrenheit degrees difference between summer and winter here in Siberia. So the humid continental hot summer climates, rainy year-round, again, thunderstorms in the summer, mid-latitude cyclones in the winter. Maritime tropical air masses are going to be important in the summertime because they're on the east coast, so there's a warm current, warm ocean, lots of evaporation, lots of humidity, lots of rain. In the wintertime, interaction of continental polar and maritime tropical air masses are going to make frontal precip, mid-latitude cyclones, warm fronts, and cold fronts working together. New York is a microthermal hot summer climate. It's hot and humid in the summer and freezing in the winter, but it's rainy every month. Thunderstorms in the summer, mid-latitude cyclones in the winter. Mild summer. So the only difference is it's going to be colder all year. Because it's colder, there's going to be less rain, less snow. So Moscow, here's a shot of downtown Moscow. The climate graph, you can see not a whole lot of rain in any one particular month. Summer is still the rainy season, well below freezing. Like negative 10 is the average temperature in the wintertime. So it's going to be warm in the summer, but well below freezing for several months in the wintertime. In fact, it looks like they've got 5 months where the average temperature is just below freezing. Although they ain't got nothing on the subarctic climates. The subarctic climates are incredibly cold, farther away from the tropics, closer to the poles. Very short growing season, but the growing season is going to have very long days, which is interesting. So here is Churchill up in Canada, showing the distribution of rainfall. Not a lot. But because it's so cold, they're probably going to still run a moisture surplus because the precip will be greater than potet. Potet is going to be low just because it's cold. It's got 4 months above zero. Churchill is the city that a couple of years ago they had to cancel Halloween because of global warming. Churchill is very popular with polar bear tourists. People go and they have these huge military buses that they take out onto the tundra, and you can see polar bears. They had to cancel Halloween trick-or-treating a couple years ago because of global warming. There wasn't enough ice for the polar bear to go hunt in the ocean, so they had starving polar bear wandering through town, and they decided it wouldn't be a good idea to have their kids in costumes that made it hard for the kids to see or run. At the same time, they also had starving polar bears wandering through town. So Churchill, incredibly cold. Verkhoyansk, here's freezing. Verkhoyansk has an average temperature in the winter of negative 45. Absolutely insane. The average temperature is negative 14. I cannot imagine living in Verkhoyansk. The polar climates have no summer. So we have 2 distinct classes of climates. The tropical climates have no winter. The polar climates have no summer. So there's 2 broad climate classifications that just have no seasons, no seasonality. Low sun angle. So low sun angle means not a lot of energy from the sun. Huge extremes of day length. If you're above the Arctic or below the Antarctic Circle, you're going to have 24 hours difference between summer and winter. Very low humidity because it is so cold. There's hardly any energy to evaporate water vapor or evaporate water. The surfaces are white, which is going to reflect energy, so it's going to make it even colder. So we have polar and highland. So this would be highland. That would be highland. You can't see it, but the Sierras, the Rockies would be highland. The Alps are highland. And then these areas are just polar, polar, polar. South Georgia Island, also just polar. So here we have the effect of elevation. So here there's scrubby little bushes, some grasses, and as you can see, as you get higher and higher and higher, it looks like most of the vegetation has dropped out, and now it's just snow and ice as you go higher on Mount Denali. So at the same latitude, you've got this wide range of climates being created by differences in elevation. Another shot showing tundra, little, probably dwarf willow trees that are able to survive somehow, and the rest of it are going to be mosses. It's a great environment if you like mosquitoes. Tundra, that's what we were just looking at, tundra, the tundra climate. So there's vegetation. I'll just back it up. I would look at this and go, oh yeah, totally classic tundra vegetation. Tundra is a type of vegetation. It's this Arctic, very low growing vegetation. Nothing really sticks up. It's all very low growing shrubs, mosses, grasses, little flowers. But tundra is also a climate. I'm not going to test you on tundra. Never above 10 Celsius, so it doesn't need to be below freezing year round. Under snow cover for 8 to 10 months, which is challenging if you're a plant. This is Mount Cotopaxi. Mount Cotopaxi is in Ecuador. It's at 26,000 feet. There's glaciers on the equator because of high elevation. So this would be an example of a highland climate. This is right on the equator. This is in Ecuador. People do serious mountaineering in Ecuador on the equator in the tropics. But because it's at 26,000 feet, it's cold enough for there to be permanent snow and ice. So the ice cap climates, ice sheet climates, those are typical of Antarctica and Greenland, and it's every month the average temperature is below zero. So there's no seasonality really, except the winter it's dark. In the summer it's light. Here we have Vostok in Antarctica going from -30. You can tell when the sun goes down, March, boom, see ya. Sun comes back up September, October, warms up to -30, and then it just gets cold. Another shot, this has got to be Antarctica because there's land. If we were at the North Pole, there wouldn't be any land masses. You could have sea ice, but these mountains indicate that it's got to be Antarctica. Polar marine climates are more moderate. No month below -7. Still cold. South Georgia Island is an example of... So you can see it's just like flirting with freezing. A little bit warmer than freezing, a little bit colder than freezing. Some rainfall. In fact, really decent amount of rainfall because of that marine climate. It's just a little bit warmer, so you get just enough, just a little bit more precip. Okay, so now we're moving from the tropical, mesothermal, microthermal, and polar climates, which are classified based on temperature and then rainfall differences. Now we're going to look at the dry climates, and those are classified first by rainfall and then by temperature. So in latitude, the most important factor, these areas are going to be found between 15 and 30 degrees north and 15 and 30 degrees south, so right in the subtropics. For all of them, precip is less than potet. For the steppe is like prairie. Fresno is a grassland steppe climate. Precip is less than potet. Semi-arid grasslands. So there's enough rain in the springtime for grasses to grow and make seeds, and then they die. So they don't need water year-round. They just need enough water to make flowers and then make seeds and then die. Too dry to support forests, but too moist to be a desert. As opposed to the deserts, precip is less than half of potet. They're under the subtropical high-pressure systems. They are dry. You could also put them inland on the rain shadow side of a mountain. Continental interiors, away from moisture, another good way to make a desert. Cold current offshore, limiting evaporation, really good way to make a desert. And if we look at the deserts, you'll see that they're off of cold current, subtropics, cold current, subtropics, cold current, subtropics, cold current, subtropics, cold current, subtropics. Well inland, rain shadow. And then also I wanted to mention again the idea that there's a core of desert surrounded by semi-desert, the steppe, and then the steppe is going to grade into savanna, monsoon, rainforest. It's going to go from desert to steppe to Mediterranean. So it goes from hella dry to hella wet. Actually goes from hella wet, drier, hella dry to dry in the summertime to wet year round. So the desert climates are classified into hot desert, where the average temperature every month is above 18. Rainfall from local convection, like Saudi Arabia. 3 million people live here. Almost no rainfall. The summertime average temperature is 104, which I find really, really terrifying. Sacramento, usually we have like a 30, 40 degree daily temperature range. So if we just say that they had a 30 degree temperature range, that would mean that the morning, if the average is 104, that would mean that the afternoon high would be 119 and the low would be like 96. Yeah, I'll pass. Just too hot. If the average temperature is below 18 Celsius, 64, then you're a cold desert. There's not a lot of them, but they're really dry. The steppe similarly is divided up into hot steppe climates if the average temperature is over 64 and cold steppe climates. These are dry. We have some in the United States. The subtropical high makes it dry in the summertime. Precip annually is low. There's also cold steppe climates, which are cold and dry, not really found in the southern hemisphere. Canada actually has areas that are steppe, where you can see it's really dry, but because it's so cold, the potet is low enough that they're able to grow in the summertime. So they have really long days. They're up here at 49 degrees north. So they're having probably 16, 17, 18-hour days in the summertime, probably closer to 17-hour days in the summertime, with enough rain to grow crops. So they can grow grain in the summertime, and then it's just snowy in the wintertime. I also included a couple diagrams. This is a hypothetical supercontinent showing what the positioning in terms of low pressure or high air pressure and warm currents and cold currents, how all of those together are going to work to make the pattern of climates that would be desert, steppe, humid subtropical, humid continental, Mediterranean, marine west coast. This would be tropical rainforest, and then tropical monsoon, and then tropical savanna. I also included this and a link. This I thought was really, really, really interesting. This is a diagram for science fiction and fantasy writers. If you wanted to create a hypothetical planet for a fantasy or science fiction story and put realistic climates on it, this person wrote an article telling you how to do that. So you've got, again, rainforest under the ITCZ, then you've got monsoon and savanna. You can see it goes higher on the east coast because of the warm current than it does on the west coast. Then you have desert because of the cold current and the high pressure. Over here, there's high pressure but warm current, so there's enough water vapor that you're going to get rain in the summertime. Humid subtropical is a mesothermal, humid continental, microthermal, subarctic, microthermal, then polar. On the west coast, it's going rainforest, savanna, steppe, desert. So there's a core of desert surrounded by steppe. The steppe, it goes from desert to steppe to Mediterranean to marine west coast as it goes from hot and dry to cool and wet. Hot and dry, getting wetter and wetter to tropical rainforest, hot and wet. So interesting article. I think if you read it, it'll help you understand why climates are where they are. It does a really good job of explaining that, as well as helping you in your writing career. Here's another map showing just the generalized Kirpins. So the A's are the tropical climates. The B, these are the dry climates. C, mesothermal, D, microthermal, and then polar. So Kirpin actually came up with a system of names and letter abbreviations. AF, AM, AS, BS, BW, BS, CSA, CSB, CFB, and then D. So the climates on the Kirpin system going from the equator to the tropics go tropical, dry, mesothermal, microthermal, polar, but with his lettering system it goes A, B, C, D, E. And that's it for this chapter. The next chapter is going to be climate change. I wish you good luck on the quiz and studying for your climates. Please let me know if there's anything that you'd like me to cover more in more detail. Like you said we needed to know this, but you didn't really tell us this about this climate. So get back to me with that if you would be so kind. And good luck.